Welcome to the Copperfield Electric Podcast.
Today, we are cutting through the noise on a topic that is, I think, absolutely essential for peace of mind.
Backup power. We are launching a deep dive into the very frustrating world of generator power failures.
You're essential, A generator is basically your insurance policy against a grid failure.
But when that policy doesn't pay out...
Exactly. And your generator fails, it is immensely frustrating and potentially very costly.
So our mission for you today is what?
We want to distill the most critical, maybe the non-obvious troubleshooting steps. We want to give you the knowledge to diagnose common issues quickly, save you some time, some money, and maybe prevent further damage to the system.
When the lights go out, you just need solutions that work. And that's what we're providing.
Right.
We're grounding this whole conversation in practical, expert advice, drawing on the deep field experience of Copperfield Electric.
They're a family-owned 24-hour electrician serving Orange County and Southern California. Their license, for anyone wondering, is #1094740.
And we're covering the exact practical steps they recommend to get your backup power, back up and running.
So we're starting with the stuff you can check right now, often without even picking up a wrench.
The easy stuff first.
We call it the first 5 checks. These are the most frequent reasons a generator stops working. If you check these 5, you've probably covered, I'd say, about 80% of all the common failures.
Okay, let's unpack this. We'll start with the most basic inputs. Number 1, and this sounds obvious, is fuel issues.
Right.
But everyone checks the gauge, so what's the deeper insight here?
It is never just about running out of fuel. I mean, if you have a gasoline generator, fuel stabilizer is your best friend.
Yeah.
Gas goes stale pretty fast.
Okay.
But if you're running one of those larger standby diesel generators, you have a much more insidious threat.
Which is?
Microbial contamination. Most people call it diesel bug.
Diesel bug. That sounds like something out of a horror movie. What is that? And how does it stop an engine from firing up? It's basically bacterial growth. It happens when fuel just sits there undisturbed, maybe with a little condensation.
So water gets in.
Right. And these microorganisms, they feed on the hydrocarbons in the fuel, and they form this sludge and slime.
Nasty.
Yeah, and that sludge then moves through the system and just clogs everything. Fuel filters, injectors. So if your diesel has been sitting unused for, say, 6 months or more, you're not just dealing with stale fuel.
You can't just drain it and refill it.
No. You often need to treat the system with a biocide additive after draining it, or the problem will just come right back with the new fuel. That's the crucial nugget here.
That is a fantastic insight. Okay, moving to the second input, which always feels like the most avoidable problem, the dead battery. The generator just won't start. So aside from checking the terminals for tightness, what are we really looking for?
You have to look for corrosion, and specifically the type of corrosion. If you see those white or blue fuzzy deposits on the terminals.
Yeah, I've seen that on car batteries. That corrosion is increasing resistance. It's stopping the current from getting to the starter. You can try cleaning it off, with a wire brush and a baking soda solution. But honestly, if that battery's more than 2 years old, especially if it hasn't been consistently charged, it's probably just reached the end of its life.
And attempting a jump start, that's really just a way to confirm the battery is the culprit, isn't it? Before you buy a new one.
Exactly. It's just a diagnostic. If it starts with a jump, the engine's fine. The battery's the weak link.
But don't rely on it.
No, don't rely on that jump. If the generator doesn't cycle and charge itself properly, that battery will be dead again the moment the unit shuts off.
Okay, that makes sense. Let's move on to the safety mechanisms. Checkpoint 3, the tripped circuit breaker.
Right. This is the generator protecting itself.
Usually from an overload. So you check it, you reset it, but you have to understand how the overload happens in the first place.
Overloads happen a lot because of starting current. It's often much, much higher than running current.
What do you mean?
Well, think about an air conditioning unit or a well pump. When that big motor first kicks on, it demands this huge surge of power. It's called inrush current.
Okay.
And if you have too many of those high-draw devices trying to start at the same time, that inrush current just trips the breaker instantly.
So the immediate fix is to reset it, but the long-term fix is what? Learning load shedding, managing which appliance starts and when.
Precisely.
Yeah.
You have to prioritize. When you reset that breaker, the generator is basically telling you, I cannot handle this much draw.
Now, you mentioned a critical warning here.
Yes, a very critical warning. If that breaker trips again immediately after you reset it, do not try a third time.
Why not?
Because that points to an internal wiring fault, a short circuit, a major power supply problem. That's now beyond simple troubleshooting.
And it's time to call in a professional.
It's a non-negotiable safety warning, yes.
Safety first. Okay. Checkpoint 4 moves back to the engine's mechanics. Air filter blockages. How does a generator tell you it's starving for air?
The symptoms are pretty clear. The generator runs rough, the engine struggles, or you'll notice a distinct loss of power.
So it's not putting out as much electricity.
Right, and your fuel efficiency goes way down. It's trying to suck air through a clogged sponge.
And that can damage the engine itself over time, right?
It can. A dirty filter leads to incomplete combustion, which can rapidly increase carbon buildup inside the engine components. The fix is simple, though. Check, clean, or just replace the filter. Yeah. Let the engine breathe properly.
Okay, and that brings us to the last of the 5 checks. Number 5 is all about structural integrity. Loose or corroded connections.
Yep, and this is just physics, really.
Yeah.
Generators vibrate a lot.
So things just shake loose over time.
They do. Over time, that constant vibration loosens connections, even if they were torqued down correctly at the start. You need to visually inspect the terminals, the ground wires, all the output connections.
And if they're loose or corroded?
That prevents proper current flow. The power gets generated, but it never gets delivered reliably. Just securing and cleaning those connections can often restore power instantly.
That 5-point checklist gets us past most of the mechanical hurdles. But now we get to the really baffling scenario.
Ah, yes.
The engine is running beautifully, it's purring, but there is absolutely no power reaching the house. You've got a happy engine and a dark house.
This is where we have to shift our focus. We're moving away from the generation components, the engine, and looking at the delivery components.
The power's being created.
But it's hitting a roadblock before it gets to your main electrical panel.
And that roadblock, 9 times out of 10, is the transfer switch. For anyone who's not familiar, can you just quickly clarify what that device is and why it's so critical?
The transfer switch is, it's basically the brain and the muscle of your whole backup system. It's required by code.
And what does it do?
It has a dual function. First, it automatically isolates your home from the main utility grid when the power goes out. Second, it connects your home to the generator's power supply.
Okay, and that first part is the really important safety feature.
It is. It ensures you don't backfeed power into the utility lines, which could be lethal for workers trying to fix the grid.
So if the engine runs but there's no power, the switch just hasn't engaged. It hasn't completed that connection.
Right. It's failed in one of 2 ways. It could be a mechanical failure, a relay, or a solenoid is physically stuck, or it's an electrical fault, usually on the control board that manages the switch. You should visually inspect the switch housing. Is the indicator light showing generator power, or is it stuck on utility?
That's a good visual check. But if you're sure the switch isn't moving, we should also check the areas right around the generator's output.
Yes. You've got to look at the output terminals and circuit board on the generator itself.
These are the last points before the power leaves the generator.
Exactly. Before it goes to the switch, you're looking for any scorched wires, melted plastic, loose fasteners. A simple diagnostic, if you're careful, is to check the voltage output right at those terminals with a multimeter.
And that leads us directly to the ultimate hardware breakdown, the alternator. If you get a voltage reading of 0 at the terminals, even though the engine is running perfectly,
then you know you have an alternator failure.
That's the end of the line for DIY.
Absolutely. The alternator is the heavy-duty component that converts the engine's mechanical motion into usable AC electricity. If its internal windings or brushes fail, it will run smoothly, but it'll produce 0 power.
So you step back.
You step back. This is an internal specialized repair. It's far beyond DIY scope and requires some serious electrical expertise.
So if it's fuel or a battery, you can probably fix it. If it's the alternator or a complex switch fault, you need to call a professional.
That's the bottom line.
So what does this all mean for long-term ownership? I mean, the best fix is always prevention. Let's look at the maintenance schedule and help you avoid these breakdowns in the first place.
Proactive maintenance is not just cheaper than an emergency repair. It's the only way to ensure reliability when you actually need it. We have to shift the mindset from reactive fixing to scheduled readiness.
Okay, let's start with the heart of the engine, the oil and filters. How often should we be changing the oil?
You should follow the manufacturer's schedule, but a good rule of thumb is every 50 to 200 hours of runtime, or at least once a year.
Why is that so critical?
Old or low oil leads to friction, overheating, and that can cause the engine to seize. It means the generator could fail permanently or just refuse to start when you need it.
And that has to be paired with clean fuel and air.
Absolutely. You have to inspect and replace the air filter yearly. Dirty air filters choke the engine. And replace the fuel filter every 100 to 200 hours.
That goes back to the diesel bug you were talking about.
Exactly. The fuel filter is your first line of defense against contaminants clogging up the sensitive fuel injectors. A clean fuel system means a reliable start every time.
Let's circle back to the battery, which we said was a huge failure point. What's the best practice for maintaining battery readiness?
You have to test and maintain the battery constantly, especially in standby units that use a trickle charger. Check the electrolyte levels, clean the terminals, and crucially, know when to replace it.
Proactively.
Proactively. Like we said, a generator battery has a finite life, usually 1 to 2 years. Schedule its replacement. Don't wait for it to fail in the middle of a storm.
And for those bigger liquid-cooled units that look like small car engines, what's key?
Temperature regulation.
Yeah.
You need to check for coolant leaks and maintain the proper coolant mixture. Running an engine like that without enough coolant is the fastest way to cause catastrophic damage.
Non-negotiable.
Non-negotiable. And finally, for a reliable ignition, clean or replace spark plugs every 100 hours or so. Healthy plugs mean efficient combustion and an easy start.
That is a pretty comprehensive maintenance schedule. But even the best maintained systems can have complex failures.
They can.
So when the troubleshooting stops working, or the problem is clearly the alternator or major wiring, that's when you need professional backup.
That is the moment to call in a licensed expert. When you've hit that wall, you've checked fuel, battery, breaker, and it still won't deliver power. That's when a company like Copperfield Electric steps in.
And what sets them apart, especially in an emergency when everyone's scrambling for help?
Availability and their breadth of expertise. They are a true 24-hour electrician. They offer 247 emergency services.
Because a power failure doesn't respect business hours.
Not at all. And their service area is huge. All of Orange County, Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, Mission Viejo, plus the surrounding areas in Southern California.
And when you're inviting someone into your home during a crisis, trust is, well, it's everything.
It is. Their team is licensed, fully insured, and every single technician is background checked. As a family-owned business, they really prioritize customer satisfaction. They offer a 100% satisfaction guarantee and competitive pricing.
So you know who's showing up at 2 a.m.?
Exactly. You know they're qualified and vetted.
And we should mention their expertise goes beyond just generator repair, which is important because the whole electrical system is interconnected.
Absolutely. They handle the entire electrical ecosystem of your property. That includes crucial panel upgrades, which are often necessary before you even install a modern generator.
Right.
They also specialize in EV charger installation and electrical for new construction, including those accessory dwelling units, ADUs, that are so popular now.
All those new electrical loads.
All those new loads require a healthy, updated main panel to ensure safety and efficiency, whether the power is coming from the grid or from your generator.
It all comes back to having reliable infrastructure. Okay, so to recap, you now know the 5 quick checks: fuel, battery, breaker, air filter, and connections. And you know the crucial signs that your running generator needs a professional eye on the transfer switch or the alternator.
And here's a final provocative thought for you to consider, something that ties us all together. We spend a lot of time on maintenance to prevent the generator from failing.
Right.
But think about the bigger picture, your home's electrical infrastructure. When was the last time your main electrical panel was checked or upgraded?
That's a good question.
A faulty or outdated panel can make overload issues so much worse, especially when you add new demands like an EV charger. It can cause those circuit breakers to trip repeatedly, even if your generator's technically running perfectly.
So your panel's health is the hidden key.
It's the hidden key to maximizing your generator's efficiency and your home's overall power stability.
A truly critical point. Thank you for joining us for this deep dive. For reliable electrical services or 24/7 emergency support across Orange County and Southern California, Copperfield Electric can be reached at 626-622-9694.